Okay, in this video we're going to discuss chapter 8 about heat. Okay, so in this chapter we're going to discuss only 4 subtopic, which is temperature of heat, temperature and heat. This is on the getting the concept of how we measure heat using the concept of temperature. Okay, so then after that we're going to use that change in temperature, which describe amount of heat transfer. So this amount of heat transfer will be related to two of this, heat capacity and the specific heat capacity. So technically this is the same thing, it's only that for heat capacity it is depend also on the quantity, but the specific heat capacity is independent of the quantity, but it's more dependent on the types of materials. So for heat capacity it depends on both the quantity and also the types of material. Okay, so then after that we're going to look upon the change of phase through continuous of heat transfer by one material having more heat. We're going to changes in phases as what we know. Example, ice, we have solid, and then we melt it into liquid, and then so through that process the solid acquired heat, so that heat is sufficient to melt the ice and to become a liquid of water. And then if this water receive more heat, and then eventually you're going to go to the what we call boiling, and then of course if we keep boiling, then all this water will be evaporate or change into steam. So that one you're going to a different phase. So that's a change of phase. So through this change of phase that I mentioned just now regarding on the how the energy is being used to change in phase from solid to liquid, so that is what we call a latent heat. So the energy, the amount of the energy required for one material to change phase from solid to liquid or liquid to vapor or steam, so that is what we call the latent heat. So we're going to able to also calculate the amount of energy required to change this material into different phase. Okay, so it can be both way. Either is from liquid, from solid to liquid, which is required to gain more energy, or it can be the other way around, which is from liquid to solid, where the material is required to remove its energy. So we're going to discuss it a little bit more details later when we go to that part. Okay, so let's go to the first part. So the temperature, I think all of us they've got familiar. So in this topic we're going to deal with only 3 of units, which is Fahrenheit, Kelvin, and also Celsius. So only that 3. So we're going to discuss how this 3 temperature different and then led to the conversion. So this conversion for these 3 different temperature will be technically different compared to what we have done before in terms of conversion, because they are having a different scale. Compare between the Celsius and Fahrenheit and Kelvin, it will not be as decimal as what we have deal with our previous units. So here, it is going to be easier for you to grasp the equation if you understand what differentiate between these 3 units. Okay, so technically in general you will see that that between Celsius and Fahrenheit, we can the way we should see this based on the reference. Okay, what I mean by reference, if you look at here, we try to look on the same reference. So the reference that Celsius use is that it start from 0, which is refer to the freezing point of water, and then it goes to the another reference, which is a boiling of water, which is 100. So the gap here, or the difference in scale here, is 100 scales. So that scale is given the name of Celsius. Okay, so going to the same scale, going to the same reference, then if we look on this based on the same reference, and then see the scaling that the Fahrenheit use between these 2 as well, freezing point of water and boiling point of water, we will see that the difference between 212 for Fahrenheit and 32 degrees of Fahrenheit is actually 180. Okay, and then not just that, the starting point, the indicating of the temperature also different. Means that here Celsius indicating that the degree Celsius at 0 degrees Celsius, the Fahrenheit is at the 32 degree Fahrenheit. So it's not just the incremental is going to be different. The incremental from the same reference 0 freezing point to boiling point is 100, whereas for the Fahrenheit the increment point is 180, not 100. So we have two things here. One is the value itself, the indicating value, which is at freezing point. Celsius is 0, whereas Fahrenheit is 32. Another one is the incremental is different as well. For Celsius is 100, whereas Fahrenheit is 180 to reach to a boiling point. So if we want to change, from Celsius, okay, so if you want to change into from Celsius, degree of Celsius to degree of Fahrenheit, so the first step is similar to what we have done before in terms of scaling. So if we remember that whenever we measure let's say length in centimeter or in meter, both of them have always going to start at the same 0 point. Means that if there's no length, both centimeter and meter will share 0 centimeter or 0 meter, right? So whenever I measure 100 centimeter, that is going to be equivalent to 1 meter, as what we know. 100 centimeter equivalent to 1 meter. So what we are seeing here is the incremental is different. So if you look at here, from between Celsius and Fahrenheit, the incremental also different. So this, we are dealing with the same here like this. So the first step of the understanding this equation is that, let's see, if we are starting with the 20 degrees Celsius, so we need to change the incremental. So the incremental would be multiply. Okay, so we need to remove the incremental of Celsius, which is 100 degree just now, 100 degree of Celsius, and then it's equivalent to 180, okay, of Fahrenheit. Okay, so then if we simplify this, then we will have this is going to be 9 over 5. Okay, so then we have 20 multiplied 9 over 5. So after this, we already set upon the increment the incremental to be fixed according to the Fahrenheit. Okay, according to the Fahrenheit. Okay, so it's just that another thing what we are missing here, although that we already changed this incremental to like this, it means that if I were to increase 20 degrees Celsius here, so it should be equivalent to increment of 432, not 36, 36. Yes, okay. So then it's going to be equivalent of 36 increase of Fahrenheit. Okay, 36 degrees of Fahrenheit. So then, but this is starting from 0. So this is 20 increment is starting from 0. It's 20. So that what we get 20. So the incremental for Fahrenheit is 36. It's only that it is not. So the temperature Fahrenheit, of course, it will not be 36. It is because it starts from 32. So from here 36, we need to add another 32. Okay, so in general, what we have done here going to be multiplication of this, and then we plus 32. Okay, so so what we have here, if I were to simplify the equation here, so this is going to be the temperature in Celsius. Okay, temperature in Celsius. So the temperature of Celsius will be the temperature of Fahrenheit, because the outcome of this will give you the temperature of Fahrenheit. Okay, so the temperature of Fahrenheit will equivalent to temperature of Celsius multiplied by 9/5 plus 32. Okay, and if you look at this equation later here, that is what we get. 9/5 multiply the temperature of Celsius plus 32. So it is recommended that you only need to remember this, or this one only, because by remember one of this, you can easily manipulate this existing equation to another equation, as what we did. I can show you right now. So if I were to remember this only, then I just move this 32 to the side. I will get TF minus 32, and then I need to move this to 95, then come 5/9. That will give you exactly the second equation. Okay, so that's how you get the first equation. So how do you change? You just apply the equation accordingly. Okay, what about Kelvin? Okay, so the Kelvin and Celsius is also it's a little bit different. Okay, as what we have discussed before, for Fahrenheit we have both of the condition. It's not just the scale, the scaling is different, but there's the starting point also different. But if you look at here between Kelvin and Fahrenheit, Kelvin and Celsius, okay, you have, for Celsius we have 100 scale of difference between the reference of freezing point of water and also the boiling point of water. If we look at that reference as well for Kelvin, we will get the same 100 degree. Okay, so then the difference between the incremental from freezing point to boiling point is the same with Celsius. Okay, it's only that the difference here is the starting point. So that makes things easier. Means that if I were to look at here, if I were to you can just look at here, at the 0 it is the Kelvin is 273.15. so it means that is the difference between the two scales is always 273.15. so the Kelvin, of course, is going to be more than Celsius, so then it's going to be very direct. So if I were to have Celsius, I want to mean the Kelvin temperature, so I just need to have the Celsius plus with 273.15, just like that. Okay, so of course, if you want to remember this, you want to have the other way around. You just manipulate this equation, and then it's quite very simple. TC will be equivalent to TK, which is Kelvin temperature, minus 273. Then you can just simply look at this. Whenever we have 0 degrees Celsius, the temperature of Kelvin 273, then if we apply this 273 minus 273, obviously going to give you 0, which is what we expected here. You can apply, you can try also for other temperature to see whether it is right, and also we look at here, we're also going to get the same. Okay, so in general, you just need to remember these two equations, or this, of course, this one for this A and B here is either one. You can remember, but just one will be enough. One for between Celsius and Fahrenheit, another one is between Kelvin and Celsius. I think this one is much more easier to remember. Okay, so for Fahrenheit and Kelvin, it's just you need to replace. Okay, I mean that replace. So let's say you want to change the Fahrenheit here to Kelvin. So here from this equation you need to have Celsius. Of course, you just change this equation from the equation between Celsius and Kelvin, TC equivalent to TK plus 273.15. Okay, so let's say if you want to change Kelvin to Fahrenheit, so then this equation you just need to replace this TC with this TC here. Then it will definitely right away will give you another form of, it will not be here because what we did just now is Fahrenheit with towards Kelvin, or you want to make a Kelvin to Fahrenheit, you can also do the same thing. Just revert the equation here, use this one equation, and then you replace the TC here with the TC this again, and then you will have the Kelvin on this side, TK plus 273.15 would be equivalent on this one 5/9 TF minus 32. So just move this one to the side, then it will right away give you the equation you require. Okay, just play about the algebra a little bit here and there, or you can simply actually do it one at a time. Okay, so means what I mean by one at a time. Let's say if you want to change from Celsius to Kelvin, I don't think you have any problem. But let's say if you want to change Fahrenheit to Kelvin, so you can always change to Celsius first, TC, over TC equivalent to what was it just now. We just need to change this. That will give us TF minus 32. With this one, this equation, TF minus 32 multiplied by 5/9. Okay. Once you got the TC, and then you can just supply this equation, then you get the TK. That one I think is much more easier. You don't need to deal with more derivation. Okay, so you can try out this and then see whether you get the answer right. Okay. Another thing that you can look onto this temperature is that we're going to see where this Kelvin is about, because Kelvin will be the SI unit for the temperature. So Celsius is another temperature, Fahrenheit is another common temperature that we're going to use in dailies. Okay, because the reference is convenient to us. But the Kelvin, the temperature is more on the scientific part, because as I mentioned just now, it's going to be considered to be part of the SI unit, not Celsius, but Kelvin is a SI unit. Okay, so why this Kelvin? What significant is the unit of Kelvin? So if you look at here, Kelvin shows us, if you look at both of the Fahrenheit and Celsius, both of them have this negative temperature. So when we go to negative temperature, technically we can go to infinite amount of infinite value of negative. So it can be colder and colder. It can be even be at 1000 negative 1000 degrees Celsius. That is on terms of numbers. So the number of negative can go beyond as far as you could, but whereas in the reality that is not possible. Okay, because the coldness is the absence of heat. So if we technically remove off the heat, then actually it already reached the absolute coldness. It means that there's no heat at all. Okay, so that is where the Kelvin play the important part in terms of it being the SI unit for temperature measurement. Okay, then if you look at here, we will see that despite of the difference between the Celsius, we will see that the below the what I call it, the smallest value of temperature is 0 Kelvin. It means that it cannot be less than 0. So this is what we call absolute zero. Okay, absolute zero. This is where the temperature is the coldest possible. It cannot be colder than this, because at this point there absolutely no energy at all for any part of the system. So if I were to say that a block of copper reached at absolute zero temperature, it means that the electron, even the electron or the atom, is not vibrating at all. Zero. It's not vibrating even the slightest. Okay, that is where it reached zero degree, 0 Kelvin. Sorry, there's no degree, 0 Kelvin. Okay, so we cannot go beyond that. So that is why the significant, then significant in terms of temperature measurement. Okay, so that's why the Kelvin. So as I mentioned before, heat is a form of energy. It's a form of a thermal energy, where this heat is always transferred from high temperature to a lower temperature, because it flows. Because as I mentioned before, just now, that the heat, coldness, something cold is actually the absence of heat. So obviously, something that is full can only flows to empty place. As what you can see, that if I were to have, I think you already know, if I were to have a full of gas here, and then beside here we don't have any gas, and if I were to remove this, of course the gas will flow to the empty vessels. It cannot be the other way around, and then the flow will immediately stop when the vessel has been equally occupied. Okay, so this concept can also be seen exactly for temperature. So this side, the empty vessel, can be considered to be a cold object, a colder object. So then this one is going to be the hotter object. So then the heat always going to be transferred from the hot object to a colder object. So it always required a significant difference in temperature in order for there to be a net flow of heat. Okay, so the amount of heat, because this heat can be also measured in terms of it considered to be energy. So then of course we're going to expect the unit also going to be joule or calorie. Okay, as I mentioned before, that the heat will always continue to be flowing to one side to another, from hot object to another to cold object, but that process, the flow of process, or as it already explained just now, is going to be stopped at the moment as soon as both of them reach what we call an equivalent hotness, where in this case we call it a thermal equilibrium. Where both of the side A and B here already reach the same hotness, or we can measure it considered to be the same temperature, where there's no net heat transfer. It's not that there's no heat transfer at all. There will be a slight of heat transfer from A to B, and also going to be a slight transfer from B to A, and then through this process it able to maintain the same temperature, what we call a thermal equilibrium. Okay, so that's all. Thank you.